Welcome, Calc class. We are working on Chapter 2, Section 2, and Day 1 of that. It is time to learn the shortcut rules to finding derivatives so that we do not have to go through the long, tedious process of doing the limit definition to find the derivative. Just a little bit of warm-up. Do you recall how to write these using rational exponents? So like the square root of x. Well, we know the index is a 2, so this is like x to the 1/2. If you recall, it's always the power over the index of the radical. And so why don't you just take a minute and fill that out and then check. So I wrote my answers out here. See if you agree with me. Do you recall how a negative exponent moves things? So this x to the -7th will move up on top. This was on the bottom, so I'm reporting it as a negative exponent. Let's go ahead and skip that. We've done a lot of that type of work. So getting into the rules, the shortcut rules. Let c be a real number. And then I have this function f of x equals c, or you could rephrase it as y equals c or some constant. Just ignore this, you guys. This is just a repeat of what that is. If I did the derivative of a constant, well, let's just say, let's practice with y equals 9 as an example. So if I graphed y equals 9, we're talking about a horizontal line at a height of 9, right? So I get this horizontal line at 9. This will be y equals 9. And I'm looking for the derivative of this function. Well, what slope is this line? Well, it's a horizontal line, so obviously the slope is 0, which means that y prime is 0. So any constant is going to graph out as a horizontal line, and we get the derivative to be 0, meaning that the slope is 0. So y prime is 0. The shortcut rule then, we just talked about it. This would be 0 because y is a horizontal line with a slope of 0. What about a linear function? So on this, I'm thinking like y equals mx plus b. If I did a derivative on this, the derivative of a multiplier times x, or a coefficient times x, will turn out to be that coefficient, or the slope when you're looking at a linear function. So a little note over here on the right, y is equal to mx is a line with a slope of m. Therefore, the derivative is going to turn out to be m. The power rule. When I have a variable raised to a power, like n, the rule is it'll be n times x to the n minus 1. Okay, so kind of think of it as I've got this power. I always think of the power coming down, and then I've got to subtract 1 from it. The sum or difference rule. The derivative of two things added or subtracted will be the derivative of each of them, and I can write that as f prime plus or minus g prime of x, showing that I'm going to take the derivative of each of them separately. The constant multiplier, I can think of c coming out front, and then I'll have c times, and I can just take the derivative of the function of f prime of x. Sine and cosine. So we're going to do two of the basic trig functions. We will learn them all, but for now, let's just be happy with doing two of them. The derivative of sine becomes cosine x, and the derivative of cosine becomes negative sine x. So a little bit of practice. Let's use the power rule, which you can probably see from up above. And the derivative of the power rule, d dx of x to the n, is n comes down, and then I get x to the n minus 1. I reduce it by a power. So if this is my function, it's going to be the 6 will come down as a multiplier. So I'll end up with 5 times 6, x to the 6 minus 1, which simplifies into 30, x to the 5th. Here, pi is shown, right? I've got this function g of x equals pi. Pi is really just a number, isn't it? We can think of it as a constant. And the derivative of a constant means that I have, like y equals pi is a horizontal line at the height of 3.14. This derivative, g prime of x, will turn out to be 0 because the horizontal line has a 0 slope. Back to using the power rule here. The 5 is going to come down and then I reduce it by a power. So I will have -7 times the 5, x to the 5 minus 1, plus the 4 is going to come down. I'll have 1/2 times 4, x to the 4 minus 1. Reduce it by a power. Turns out that I'm going to have -35 x to the 4th plus 2 x to the 3rd. That's a whole lot easier than doing the limit. You know, and I need an f prime sitting here. I don't want that to look like it continued one long string of things, and f prime of x equals. Here the power is going to come down, so I'm going to get y prime equals 8 times -3 times x to the -3 minus 1. Be careful with these negatives, it's a little different, isn't it? I'll get x to the -3 minus 1 makes this -4. It reduced it by a power. -3 moves to -4. On this one, x to the square root of 2, well, this is a number. It'll just come down. So I'll have f prime of x, the derivative, is equal to the square root of 2, x raised to the square root of 2, and then I subtract 1 from that. Make sure your radical bar does not extend over the 1, though. And finally, well, I could think of this as having a power of 1. So I'm going to bring this 1 down in front. F prime of x will equal 1 times x to the 1 minus 1. Reduce it by a power. F prime of x turns out to be x to the 0 power. Oh, f prime of x is just 1 on that one. They're kind of fun. They're pretty easy. The power rule is an easy one. You will use it all the time. And so much faster than using the limit of f evaluated at x plus h minus f of x. Now, for a little bit more complicated ones, my suggestion is going to be to rewrite it first, then to take the derivative. So what do I mean by that? Well, let's rewrite this as -2/3. I see the fraction, don't you? And then I've got x to the second on the bottom. That's going to be like an x to the -2 if I rewrite it. Now I can differentiate it using the power rule. And that means let's bring that -2 down. So we're at the derivative. Make sure you got f prime of x written. -2 times the -2 on top will make it'll make +4/3. X to the -2 minus 1. Simplify this out, and we're talking 4/3 x to the -3, or 4/3 x to the 3rd, dropping that negative power down below. Rewrite f of x. I'm still just with the original function, just rewriting it. Okay, the 3 gets applied to each of those, right? So I really have pi over 4 to the 3rd, and then I've got this x to the -3. Let's take the derivative now. F prime of x. The -3 comes down, so I'll have -3 pi over 4 to the 3rd, which is 64. And then I'll have x to the -3 minus 1 more, drop it by a power. And final answer will be -3 pi over 64, x to the -4, -3 pi over 64, x to the 4th on the bottom. Why don't you try to do the next one by yourself? Okay, I wrote mine out. The -3 power came up, so I had 4x cubed, and then I just had to use the power rule to take the derivative, and you can see my answer over on the right, 12x squared. Oh, this one looks super weird, doesn't it? Well, let's rewrite it first. F of x. So it's got a square root. that's like a 1/2 power. So I'm going to have x, I'm sorry, 1/2. Yeah, 1/2 power would make sense, wouldn't it? I was going to say this is all over 2, but you're going to see why. So I could write it like that, where I have, here's my inside piece, x to the 2 plus pi, and then the outer indice is a square root, so it's a 2. That's a 1/2. Now let's distribute this through and see what happens. So we get f of x is equal to x 1 plus pi over 2, correct? Take the derivative, f prime of x. Well, the power comes down, so let's bring our power down. 1 plus pi over 2. I'm going to put it in parentheses because it's multiplying by our x. And then we're going to have 1 plus pi over 2 subtract 1, because we got to reduce it by a power. And 1 minus 1 will go away. So we will get f prime of x is equal to 1 plus pi over 2 times x to the pi over 2. Excellent. Next page. Oh, next page for me. And then it really goes on the same way. I'll let you try 39, so why don't you hit pause and use the power rule on it and see what you come up with, and then we'll set up for number 46. There is my final answer. Remember, on this middle one, you were taking the derivative of a constant, and that derivative is 0. All right, for 46, do you see how this is multiplication? And I haven't given you the rules for how to take the derivative of something multiplied. We'll get to that. There's a product rule. But for now, let's skirt around doing the multiplication by let's distribute first. So let's simplify this by distributing. So that's going to give us, what, 18x squared and a minus 15x cubed. And now it becomes a simple problem like we had just kind of done. Let's take the derivative of it. So y prime power comes down. I'm going to have 36x minus 45x to the second. Those are easy now, aren't they? Kind of like those. And then 51, rewrite it. You know, I have kids in Calc 2, and they still like to switch up that radical and write it as x to the 1/2. Eventually, you do get used to a pattern for it, and after you do a few of them, you'll catch on to there's a pattern. Y prime equals, okay, the half comes down, so I'm going to have 6 times the half, x to the 1/2 minus 1 plus 5 times the derivative of cosine. If you want to look at the forward page where we did it, it turns out cosine, the derivative of it, turns into negative sine x. All right, and then let's just clean this up. 6 times a half is 3. X to half minus 1 is a negative 1/2 minus 5 sine x. One final cleanup, 3 over x to the 1/2. Ah, that's like a square root, isn't it? Of x minus 5 sine x. Essentially, when you take the derivative of a square root, it ends up falling to the bottom because of that negative 1/2 power that is a result of subtracting 1 from the positive 1/2, like we see here. There also is this 1/2 that sits in front of it. For us, it reduced with the 6. Okay, so then finally, the last problem, use the derivative feature on your calculator. Okay, the cool news is that our calculator can take derivatives that are numeric in value. So as long as I have an x value to evaluate it at, I can do it on my calculator. So grab your calculator. I'm going to hit pause here and get my calculator ready. All right, I got my calculator all warmed up. Hope you got yours turned on too. Go ahead and find the derivative feature. On the 84s, go alpha F2, and it'll be number 3. Let me get this turned so it stays on the front. All right, so it was alpha F2 is one of the shortcuts to it. Option 3 is numeric derivative, and it should look like that when you get it up. I want d dx, so I'm doing it with respect to x, so grab your x variable, In the function area here inside the parentheses, we're going to go 3 minus 3. I'm going to go ahead and build a fraction. Oops, I didn't hit the right key, sorry. Let me get back over. I'm going to put my fraction, insert that into its spot, and then I can really see that I've got this keyed perfectly. There's the 5x. Now, here's the kicker. At the end, we need to put in the number that we were going to evaluate our derivative at, and that was at 3/5, so 3 divided by 5. This is the ordered pair, and 3/5 is the x value. So your screen should look like that. Hit enter, and there is the result. The 83s take a little bit more work. If you have an 83, let's talk in class and I'll show you how to get it inputted. Or if you'd like, do a Google search and you can probably find it as well. Very good. We will work on some homework in class tomorrow.